Okay, these are the notes for section 5.3, Solving Trig Equations. We are on part 2 or day 2 of our notes. So let's just get started. We're going to solve this first equation, sine of x plus 1 minus cosine x equals 0. Now looking at it, I have no squared terms, so I'm not going to be able to substitute any of my identities. And I can't change anything, otherwise I'm going to end up, if I try to divide by sine or cosine to get a tangent, then I'm going to bring in one of my other reciprocal functions. So the best thing for me is I am going to isolate the sine x plus 1 by moving the cosine x to the other side. Now the reason I'm choosing the cosine x is because of the fact it has a minus sign. And I want to put my two trig functions on either side of my equation. I don't want them both on the same side. The reason I don't want them both on the same side is because I'm going to end up squaring both sides, and then if I do that, then I end up with something not so nice to look at. So let's move that over. And now I want you to square both sides. Multiply it out. Pause your video while you multiply it out, and then check your answer with me. And should have ended up with sine squared x plus 2 sine x plus 1 equals cosine squared x. Now the only drawback with doing what we just did, where we squared both sides, is we went from having a variable that's to the first power to having a squared power. Thereby we've added in some new solutions. Now these new solutions may not work, so when we're all done with everything, we're going to have to check our answers and see if we have any extraneous ones that we're going to have to throw out. Alright, now looking here, we still have our sine squareds and our cosine squareds and stuff, but I can substitute 1 minus sine squared in for that cosine squared. So let's do that. So we only have one trig function, and that's going to be sine of x. So we're going to get rid of that cosine squared by putting in 1 minus sine squared. And that's the most ideal thing, is to get everything to be the same trig function. Now move everything to one side, make it equal 0. So pause your video and do that for me. And now that we've moved everything over, we end up with 2 sine squared x plus 2 sine x is equal to 0. I can factor out 2 sine x. Solve using zero product property, and I get 2 sine x equals 0, and sine of x plus 1 equals 0. And that gives me the sine of x equals 0 and sine x equals negative 1. Okay, so going back to my graph, I know that sine of x equals 0 at x equals 0 and pi, and sine of x equals negative 1 at x equals 3 pi over 2. Now a couple things we can do at this point. We can put all of these on the graph and then check our solutions, or we just do that right now. And I think I'm just going to do it right now. So we need to check all three of these. We need to check the 0, the pi, and the 3 pi over 2 in our original equation. So let's do our first check. So I'm going to try the 0. I'm going to go sine of 0 plus 1 minus the cosine of 0, and we're going to see if that equals 0. Well, sine of 0 is just 0 plus 1. Cosine of 0 is positive 1, so that's minus 1 equals 0. Looking at that, that's going to check. That's going to be a good solution. We want that one. Let's do the next one. Let's try pi. So we want the sine of pi plus 1 minus the cosine of pi equals 0. Well, sine of pi is 0 plus 1. So far it's looking good. minus the cosine of pi, well, that's negative 1. Well, I'm going to end up with 2 is equal to 0. That's a no-no. Oh, no. Uh-oh. That's not good. So we're going to go and cross off that pi. It's not a good solution, so I'm going to just cross it off. Now let's check our last one, the 3 pi over 2. So the sine of 3 pi over 2 plus 1 minus the cosine of 3 pi over 2 equals 0. Well, sine of 3 pi over 2 is negative 1 plus 1 minus the cosine of 3 pi over 2 is 0 equals 0. Yep, that's going to give me a 0. Yay! So there's our two solutions, 0 and 3 pi over 2. And if I were to look at my graph that I have, 0 is here, and 3 pi over 2 is down here. They're not going to be the same distance apart. So I'm going to need to write two equations for my final answer. And let me see, where am I going to do this? Let's do that way down here at the bottom. So x equals 0 plus or minus 2 pi n, and x equals 3 pi over 2 plus or minus 2 pi n. Okay? And there's our first one for today. So again, remember, if you end up having to square both sides, you want to check your solutions because you can get an extraneous solution. And it generally only occurs when you have when you square both sides. It's always a good habit to just go back and check solutions anyway. Okay, so let's go on to number 2. Okay, here's number 2. We have the cosine of x plus 3 is equal to 0. I'm going to solve for cosine, and I get the cosine of x equals negative 3. And I need to stop and look at this and say, wait a second. Cosine can't, the biggest it can be is negative, is 1. The smallest is negative 1. Well, negative 3 is not in that value. So again, we know that cosine has to be between negative 1 and positive 1. Well, negative 3 falls outside that range. So this one cannot occur. So, hey, this one's easy. It's a no solution. Because remember, again, we're dealing with a unit circle, and the radius of our unit circle is 1. So our values have to go between the negative 1 and the positive 1. Hey, that was easy peasy lemon squeezy. Oh, let's move on to number 3. Okay, so we have the equation 4 sine squared x plus 2 square root of 3 sine x minus square root of 3 equals 2 sine x. Before you freak out, it's not that bad. I know you're looking at all the square roots and you're probably thinking, no, don't freak out. First thing we want to do is just move everything to one side. And I'm actually going to kind of rearrange this a little bit, and I'm going to put the 4 sine squared first. Minus the 2 sine x plus the 2 square root of 3 sine x minus the square root of 3 to make it equal 0. And the reason I'm doing this is because I'm going to have 4 terms. The likelihood is I'm going to be able to factor by grouping. And so I'm going to put those square roots in the same factor, or right next to each other, so I can factor it out. So in my first parenthesis, that's right here, I can factor out 2 sine x. And that leaves me with 2 sine x minus 1. In my second set of parentheses, I can factor out square root of 3. And same thing, I'm going to end up with 2 sine x minus 1. Continuing with our grouping, I get 2 sine x minus 1 times 2 sine x plus the square root of 3 equals 0. Apply my zero product property, and that gives me that this 2 sine x minus 1 equals 0. 2 sine x plus square root of 3 equals 0. So I get that the sine of x equals 1/2, and the sine of x equals negative square root of 3 over 2. Well, I know sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. And sine of x equals negative root 3 over 2. Well, that occurs at 4 pi over 3 and 5 pi over 3. So let's put these all on our graph and see how they look. Okay, well, pi over 6 is over here. Five pi over 6 is here. 4 pi over 3 is down here. And 5 pi over 3. Now looking at these, if I gave them all the same denominator, just to kind of check my placements, I know that this would be 8 pi over 6, and then this one would be 10 pi over 6. And from pi over 6 to 5 pi over 6, that's 4, and then it goes from 5 to 8 is 3, and then 2. So they're not the same distance, but what about if we pick some other ones? Well, pi over 6 to 8 pi over 6 is 7. We're adding 7. If I add 7, I get 15. And that's not going to get me back to 1 pi over 6. So I'm not going to be able to wrap these all together. So I'm going to end up having to write 4 equations for this. So let's just do that. X equals pi over 6 plus or minus 2 pi n, comma, 5 pi over 6 plus or minus 2 pi n, 4 pi over 3 plus or minus 2 pi n, and 5 pi over 3 plus or minus 2 pi n. Okay? And that is number 3. Let's move on to number 4. Okay, number 4, sine of x minus cosine x equals 0. Alright, so again we have 2 different functions. None of them are squared, and nothing that jumps out at us that we can substitute in. So this is one of those rare occasions where we are going to want to divide, because divide by either sine or cosine. Now, at the very beginning of all our notes for solving, there was the big, no, you can't divide. Well, that's true, you can't divide to get rid of, but we can divide to rewrite. So if I divide everything by the cosine of x, what happens is that cosine gets incorporated in this first term as tangent. The cosine's still there, it just looks a little different. Minus 1 equals 0. Now just solve for tangent. So the tangent of x equals 1. Well, I know tangent of x equal 1 occurs at pi over 4 and 5 pi over 4. So So let's look at our graph for that. Pi over 4 occurs right here. And 5 pi over 4 is over here. So they're distance of pi apart. So I can say my answer is x equals pi over 4 plus or minus pi n. And again, this type of a problem is a case where if I am not getting rid of cosine, I am rewriting it. And that is something that we are allowed to do. Okay, that's number 4. Let's move on to number 5. Okay, number 5 has the cosine of 4x is equal to negative root 2 over 2. You're probably wondering, okay, what is this 4x? Well, we're going to just solve it the way we normally would. It's just instead of having just an x, we have a 4x. And so I'm going to just put a little parenthesis around this. And so I want to know where is cosine equal to root 2 over 2. And so that normally occurs at 3 pi over 4 and at 5 pi over 4. Okay, so looking again at my graph, 3 pi over 4 is over here. 5 pi over 4 is down here. Easily we can tell by looking at a graph they are not equidistant. So what I'm going to do is I'm going to write my equations like I normally would. So our first equation is going to be 4x equals 3 pi over 4 plus or minus 2 pi n. And our second equation, I'm going to give myself a little room. It's 5 pi over 4 plus or minus 2 pi n. Now here's where that 4 comes in. I don't want 4x, I want x. And what we normally would do is then divide this by 4. Well, if I divide my left side of my equation, I have to divide my right. So I'm just going to divide everything by that 4. That's going to give me x equals, multiply your denominator, so 4 times 4 is 16, so 3 pi over 16, plus or minus 2 over 4 is just pi over 2, n. Okay, so there's that equation. Now do the same for this one. Divide by 4. X equals 5 pi over 16, plus or minus pi over 2, n. Alright, that's equation 5. Let's move on to equation 6. We're going to just put equation 6 here on the same slide over here on the right. And again, there's something strange where our x is. We have x over 2. And we're not going to do anything differently than what we just did. I'm just going to put parentheses around this. I'm going to keep it grouped together. And I'm just going to solve for tangent like I normally would. So I'm going to move the 3 over. 3 tan of x over 2 equals negative 3. Divide by 3 and I get tangent of x over 2 equals negative 1. Well, where is tangent equal to negative 1? That occurs at 3 pi over 4 and 5 pi over, not 5 pi over 4, 7 pi over 4. And knowing what we know about tangent, that is over here and over here. So they are pi apart. They are equally spaced. So we can write one equation this time, and that would be x over 2 equals 3 pi over 4 plus or minus pi n. Now, with the previous problem, we divided by 4. to get x by itself. Well, now we have x divided by 2, so to get rid of that 2, I'm going to multiply both sides by 2. Okay. And that's going to leave me with x equals, well, 2 times 3/4 is going to be 3 pi over 2, plus or minus 2 times pi is 2 pi. Okay, so our final equation, our solutions are x equals 3 pi over 2 plus or minus 2 pi n. Alright, that concludes the notes for Chapter 5a. If you have any questions, make sure you come to class with them.